Now in this video, we're going to talk about third law force pairs. So those forces that are interacting with each other that we can use Newton's third law to show are equal between free body diagrams. So we have a situation here where this poor kid is taking a volleyball right to the schnoz. And what we want to do first is create free body diagrams for some major objects in the system. So I'm going to focus on the volleyball and the kid's face are the two objects that we're concerned about. So if I draw my volleyball as a point mass right here, looks like we have an applied force going backwards, and I am not going to have angles in here just to for sake of ease. So we have an applied force on the volleyball. We'll say VB. By the face. And it looks like it's pushing it kind of in the left direction. And again, it definitely looks angled, but we'll kind of approximate it as being to the left. And we also have a force going down because we have gravity. So force of gravity on the volleyball by the earth. And really, it looks like it's about it. Notice how we don't do the applied force of the hit because that is not in contact with the object in question. So now let's do the face. Let's see what forces might be interacting there. So if we treat the face or the head as its own object, there's a force of gravity pulling down on the face or the head. So I'm going to approximate that as face pulled down by the earth. We also have a force from that volleyball just smacking him in the face, and it looks like it's pushing to the right. So we have an applied force on the face by the volleyball. And I'm assuming to keep that kid's head up, there's got to be some sort of a normal force. So I'm going to say that there's a normal force on the face or the head by the neck. So we have to make sure that the kid's head is propped up. Okay. So it looks like the face or the head is not being accelerated up or down, so I can probably say that these two are equal to each other. Now, as we look at the force diagrams, though, Newton's third law tells us that for every action, there's an equal and opposite reaction. And so that is between multiple objects. So anytime there's an interaction, there must be a force that is equal and opposite. And if we look at our forces, we have an applied force on the volleyball by the face and an applied force on the face by the volleyball. So that's a really good signal that these are third law force pairs. So we can say that the applied force on the face by the volleyball, so that kid getting smacked right in the kisser, is equal to the force on the volleyball by the face. Now, I'm sure that doesn't really come as a consolation to that kid, but physics-wise, it's a nice example to kind of talk about. So what I'm going to do is I can do some congruency lines between force diagrams as well. So I am going to kind of do a double congruency line over here, and since according to Newton's third law, that one must be equal to this one. So if we get into more quantitative analyses, we can use that clue to help us find some forces within those systems. Now, if you're still a little bit stuck from those free body diagrams and you're not sure how it's showing the third law, the other thing that might help you out is by drawing a system schema diagram. So we can do the same thing with the objects in the system. So let's focus on the volleyball. Let's focus on the face. Let's focus on the neck, maybe, if we want to throw the earth in there. So we want to find all of those different interactions going on. So we've got the force of gravity between the volleyball and the earth, between the volleyball, or excuse me, the earth and the neck, between the earth and the face. Between the face and the neck, we have a normal force propping it up. So there must be a normal force acting on the neck from the face as well. Let's see, what else do we have? We have our normal force already done. We've got force of gravity on the face. And then we have that interaction between the volleyball and the face. So notice for a system schema diagram, we draw double arrows. And what that represents is that whatever force the volleyball is applying to the face is also applying to the volleyball. So it's just another way of translating what Newton's third law is telling us, the equal and opposite reactions. So on a system schema, we show that by doing double arrows. On a free body diagram, we show that by showing congruency between force diagrams. So if we wanted to find other third law force pairs, we just have to look for more double arrows. So between the earth and the volleyball, there's the force of gravity. And that's a pretty easy idea, where the earth is exerting a gravitational force on the volleyball. But at the same time, the volleyball is exerting a gravitational force on the earth. And that is equal and opposite. So while the volleyball may drop, and that's visual when we drop a volleyball, so we have that gravitational attraction, the earth is actually gravitationally attracted to the volleyball as well. But since the earth is so massive compared to that volleyball, it's nearly immeasurable to show the attraction or the acceleration just like we show for the volleyball. So the same thing happens between the earth and the face. There's a gravitational attraction of the earth to the face and the face to the earth. There's a normal force between the neck and the face that works both ways, and a force of gravity between the earth and the neck and the earth. So if you get stuck on these third law ideas, always use that system schema and the double arrows to help cement that understanding that if you are applying a force to something, that object is applying a force that is equal and opposite to the force that you apply.